Okay, tell me how we can solve this first question. Yes,
Sir,
am
it's
I
a
audible?
mirror, sir.
Okay, so it's talking about a smooth, shining surface. Okay, so it's talking about surface. So in that way, we will find a we will try to find any object which has a surface. So it's talking about a surface which rebounds the light back in the same or in different direction. So reflection of light cannot be possible because we are searching for a surface, and point of incidence is also not possible because point of incidence is a name of a place. Okay, name of a place where the incident ray and reflected ray meet. This is point of incidence. But since we are talking about a surface, so we cannot take these two. That remains a lens or a mirror. Okay, so we are talking about a smooth, shining surface. So that means it is a mirror. Anyone have any difficulty in this question? Okay, now let's move to question number 2. Beam of light striking the reflecting surface is called. What it is called?
Incident ray.
Incident ray. Good. Fine. Now the third question. In case of reflection of light, the angle of incidence and the angle of reflection are related as?
I is
Angle
equal
of
to
incidence equal to angle of reflection.
Very good. So I equal to R. And from last class, we have seen one type of problem in which we concluded that angle of incidence is always equal to angle of reflection. Okay, so angle of just a minute. Angle of incidence is always equal to angle of reflection. Okay, and tell me what are two types of reflection we have talked about.
Regular reflection and diffused or irregular reflection.
Oh, good. So reflection are of two types. One is regular and one is diffused.
Irregular or diffused.
Okay, what is difference between regular and diffused?
So, if you see from a wider perspective range, in a regular reflection, the light scatters in a specific or defined manner, where the angle of incidence is equal to the angle of reflection. And in diffuse reflection, the light doesn't reflect in a specified manner.
Okay, good. But we can simply write it as in regular reflection, I equal to R.
Okay.
Whereas in diffused reflection,
The
as
light
a
is
we
scattered into different directions.
in different directions, as a whole, we it seems that I is not equal to R. Okay, in diffuse reflection, like I explained you in last class how we if we move to the microscopic level, that means very if we zoom the part of a surface, so if we zoom it, if we make it big, we see that the light always follow I equal to R. But as a whole, if we see that surface, it looks like that angle of incidence is not equal to angle of reflection. So we are talking about like everyday life, like that means uh, regular example of regular reflection is mirror. In mirror, we can clearly see that I equal to R. And example of diffuse reflection is take any surface which reflects and it is rough. So it won't give I equal to R, but it will give slightly different angle. I something different and R something different. So regular reflection is for smooth surfaces. It's for smooth surfaces. And diffuse reflection is for rough surfaces. Anyone has any doubt?
No, sir.
Okay, great. Then, so I is always equal to R. Don't get confused in this. Why I am writing I is not equal to R in this diffused reflection, whereas I am saying that I equal to R. Okay. Ask me if you have any doubt. Number 4. What is the angle of incidence of a ray if the reflected ray is at an angle of 90 degree to the incident ray?
45 degrees.
45 degree.
45 degree. Very good. Any student have any problem in this question?
No, sir.
Okay. Okay, great. Now, number 5. If the angle of incidence of light falling on a plane mirror is 30 degree, what will be the angle of reflection?
30
30
degree.
degrees.
30 degree. Very good. Now, sixth question. When we stand in front of a dressing table, our left hand seems to be right and right hand seems to be left. This is called
Lateral
Lateral.
inversion.
lateral inversion. Very good. Is Likita there?
Yes, sir.
Okay, Likita, it's lateral inversion, not left-right confusion. Okay, we call this phenomena as lateral inversion. Like first attend all of my recorded class. Like there is property of a mirror. If this is a mirror, and if we have written B in this side, okay, so the reflected image will appear as like this. Okay, that means if this B is facing to the right, its image will face to the left. So this is known as lateral inversion. We are changing its faces, or you
Back.
can say yes.
Okay, sir.
Okay, so this phenomena is known as lateral inversion. Uh, if you find difficulty in understanding my handwriting, you can tell me at any point. Okay. Usually also it is not so good, and today also I could not find any table. Number 7. Which of the following is not a luminous object?
Moon.
Moon. Very good. Anyone has any doubt?
No, sir.
Okay, good. Now number 8. If light falls perpendicular on a plane mirror, what will be the angle of reflection?
0 degree.
0
0
degrees.
degree. Very good. Some of you must have an doubt in this question. Okay, you can ask. It is same as it is like same as that question I asked you in last paper, but little bit the language is different. Okay. Hmm. No one, no one has any doubt.
No, sir.
Okay,
No doubt.
let me explain this again, because some of you have done it wrong. Like you, some of you did 90 degree. So 90 degree is not correct. We are talking about angle of reflection. Okay, tell me what are the two laws of reflection?
So the angle of incidence is always equal
Angle of
to angle of reflection, and the
the
point of
incident
incidence, the point of reflection, and the
plane will
perpendicular
lie
will
on the
lie on the
same
same
plane.
plane and on the same point.
Okay, great. We cannot say same point, but the incident ray
Shouldn't we see on the
reflected.
same point, sir?
See, these are rays, so these are like this. So how can we say that these are at the same point?
Okay, got it. I mean, they are meeting at a similar point.
They are meeting at a similar point. That is correct. Okay,
Yeah.
but we are talking about a plane. So plane means
I mean,
the,
they are
the
lying on the same point. Isn't that true?
they
This,
are intersecting at same point. You can say that they are intersecting at same point.
okay.
Lie cannot say. Lie means that the whole body. That means see there is some ball and you are saying that it is lying on a table. That means the whole ball is sitting on this table.
Okay.
Whereas this ray is like these are intersecting at this point, and this ray has infinite number of points.
So
Okay.
can I mention that they all lie on the same plane and intersect on the same point? With the
You
same
do not have to say anything about point. You just say that like this is the language of law. So law says that the incident ray, reflected ray, and the normal to the let's say
normal is perpendicular to the plane
yes, normal is perpendicular. Yes. So incident ray, reflected ray, and normal. These all lie.
on the
These
same
all
plane.
lie on same plane. Okay. Now, so in this question, okay, I was talking about these two laws. So these are two laws. Angle of incidence is always equal to angle of reflection, and incident ray, reflected ray, and normal. These all lie on the same plane. You can say normal to the mirror.
Sir, in the
Just
first law, you did not put the angle symbol.
okay. I am not putting this one because how can I say, like in your class, in your school, when your teacher taught you this topic, have they used the same symbol, this one?
Sir, the
Yes,
teacher did
sir.
not teach us this topic yet.
They didn't teach us this topic yet.
Okay, they didn't teach you. Okay, fine. But
Sir, in my
okay,
school they use
they use what they use?
angle symbol.
Angle symbol like this, like this.
Yes, sir.
Okay, great. If they okay, you don't mention this angle symbol, you just write I and degree. This. No, don't write it. Okay, you can mention it like this. Okay, this
Sir,
line. Yes.
I also got one more definition of why angle of incidence is always equal to angle of reflection.
Okay, tell me.
When they say incident ray, reflected ray, and normal all lie on the same plane, a plane is always defined as a uniform surface and not an irregular one.
Yes.
So a plane is always the smallest part, I mean, which is in the definition itself. I mean,
Mm.
as the second law of reflection, we can say that angle of
Mhm.
incidence is always equal to angle of reflection.
Okay, you are
Consider an irregular surface of wall as
Mhm.
plane. Is it?
Okay. There is a single error in this.
Yeah.
Like say this is plane. Okay. Okay, I do not have to make a plane, since this whole paper you are seeing, this is itself a plane. Okay. Do you agree with it?
What the
The
whole?
screen, the
Yeah.
screen
Plane is
which you can
equal.
see. Okay, so this screen is itself a plane. Do you agree with this?
Yes, sir.
Okay, so this screen is a plane, and if I and if I select this single paper, so this is also a plane. This whole paper is a plane. Okay, flat. So similarly, if I say in this plane, I have written one ray like this. So this follows that I is equal to R. Let's say I have made a random ray, okay, random ray like that of diffused. This
Okay.
is going like this and this is going like this. Okay, so
Is
you
the yes, sir.
so in this case I is not equal to R. Okay, I have made just random ray because we are not talking about particularly this reflection. There are many phenomena others also. So according to your definition, any ray which any ray, okay, any ray which is this ray and this ray and this normal which lie in a plane, then angle of incidence should be equal to angle of
Sir,
reflection.
angle of incidence is always equal to angle of reflection, sir. Because on a small particle, we take
Mhm.
angle perpendicularly to that, which angle that any small like bump is there. So you can even in that case also angle of incidence will be equal to angle of reflection with respect to the normal of that small thing.
Okay, I agree with you that if in all the cases, angle of incidence should be equal to angle of reflection. But you cannot generalize anything like that. You said that if in a plane there is an incident ray and reflected ray, okay, there is normal, then there will be angle of incidence equal to angle of reflection.
Sir,
So the example you drew just right now, I mean, you explained me right. The second one you just raised
Mhm.
right now was
Oh,
the random ray you drew a regular surface or irregular surface?
okay, let me take a rough surface. Okay, now let me take a rough surface. I'm not talking about regular or irregular. By the regular you mean there is not this discontinuity. Irregular surface means that there is some bump, or you can say there is some dip kind of. So these two are irregular surface, but this flat surface is a regular surface. Now in this surface I take a diffused ray, diffused reflection. Okay, some
Okay.
diffused reflection like this, or if this is not depicting correct, I take it like this. Okay, I have taken a diffuse reflection. So in this case, can you saying angle of incidence equal to angle of reflection?
No, sir.
No.
But
So
why
we
the isn't the plane like the plane is regular? It doesn't have any bumps on it, right? Why is
okay,
it?
plane is regular, no problem in plane. Okay, the problem is with this surface.
Sir?
Okay, this surface which has I equal to R, this was smooth,
Okay.
whereas this surface which does not make I equal to R, this is rough. Okay, at microscopic level, we say that I angle of incidence equal to angle of reflection.
sir, even if it is rough, if you draw the can you draw the microscopic one once? Like if it has once bumps.
Yes, it
So
Even then, if a particle or something is tilted, like for example, if one small hill or groove is tilted, if a incident ray is falling on it, so that one particle will have its own normal, the own and with, with respect to that normal, the incident ray and the reflected ray will be equal, sir.
hmm, how can I explain this? That if let's say you are able to see this thing, okay, you are able to see this thing that this ray is like much more diverted than what it was incident. Let's say if this was 30 degree, this was 60 degree. You can by your naked eyes you can see this. But if we use microscope or anything else which will make this thing enlarge, on that surface you will say that no, this is almost like 45 degree, and this is also 45 degree, I equal to R. Okay, so hmm,
Sir, the the reflection happens, but
mhm,
on a microscopic level, if you see, it is basically um, all particles will have the different like a separate normal, and then with respect to that normal, the incident ray
mhm,
and the reflected ray um,
mhm.
are equal. Like angle of incidence and angle of reflected ray with respect to the particular normal of the a particular particle which is tilted
Yes,
or
yes,
hill or groove.
I got
Then,
it. I got it. Ashut, I understood what you are trying to say.
but if we
Right.
take on a general way, like the whole surface, whole plane,
Mhm.
then we can say it is a diffuse reflection, or it is angle of incidence is not equal to angle of reflection.
Correct. Correct. Hmm. So the main doubt was like how, Karthik said that if we take any plane and in that plane there are an incident ray, there is reflected ray, then there will always be angle of incidence equal to angle of reflection. Okay, you can write this definition, but you have to uh, mention that for small uh, for small incident for small incidents. Okay, so for your understanding, Karthik, are you there?
Yes, sir.
Okay, for your understanding, you told me about your definition. So you can say that definition only when you say that we are doing for small incidents. Okay, for
Mean-
small incidents means we are working on a small surface. Whereas for a large surface, that might not be true. Did you get it? Why
means,
it not be true?
I mean, sir, a large surface cannot be called as a plane because plane is perfectly defined as a smooth surface which doesn't have any bumps on it.
No, no, no. We
Physics, I just have asked ChatGPT that can we call a rough surface a plane? It told no, both in
no.
math.
You said smooth and irregular.
Yeah,
That
actually, yeah, I reckon that.
okay, not smooth and all that. You cannot say an irregular surface as a plane.
Okay,
Okay, but irregular surface also comes in a plane.
okay,
Let's say this whole
got it, sir.
got it.
Yeah, got it.
Let me explain to others also. Uh, let's say I have taken this page. Okay, and in this page, I make a line like this. So this line is an irregular line, but this plane is a regular one. How? Because it is uniform. But I have made a irregular line, which is not straight. Okay, did you get? So line is different and plane is different. Plane as a whole is always regular. Fine. So how? Okay, don't let's not create more confusion. Is this doubt clear? Okay, Karthik, is your doubt clear?
Yes, sir.
Okay, great. So what we were talking about? We were talking about this question, eighth question. Okay. Hmm. So in eighth question, forget the last one, the last question which I put in last paper. Like
Sir, the
it,
fifth question was not clear, sir. I did not. It was not clear, sir, because if the angle of incidence falling on a plane mirror is 30 degrees, angle of
Mhm.
incidence means the angle of incidence like related to the normal. It's with respect to the normal, we call it angle of incidence.
Mhm.
Or if we like in the previous class, you told um, the the angle at which the incident ray falls on the plane mirror, we can say that we can if we say
Okay,
in
there
that
is
way, then it
difference
is
between these two. Okay, there is difference between these two. Okay, and there in that question, that was that light is incident at 30 degree with the mirror. Okay, so
uh, in this.
listen to me, you will your doubt will be clear. Okay, so there is difference between when we take what reference we take. Do you understand by reference, this term
Yes,
reference?
yes, yes, sir.
Okay, so if I take this mirror, this is mirror, so this is a reference. If I take this normal, so this normal is also a reference. So it depends upon our perspective which one we are taking. So if I take mirror as a reference, that means the angle is 60 degree. If I take the normal as a reference, that means the angle this is 30 degree. Now, now what is difference between you are saying and written in this question? So if I say that the light is incident at 30 degree with the mirror, that means this is light, and with mirror, okay, with mirror it is making 30 degree. Fine.
Yes, sir.
Okay, with mirror. Whereas when there comes at the angle of incidence, this angle of incidence, so this and incidence, what was the definition? CE. Okay, so the angle of incidence, whenever this term appears, this whole term, angle of incidence, so that means we are measuring angle with normal. Okay, so we will make a surface like this, we will make a normal, and we will measure this angle 30 degree. Okay, so this when there is a term mentioned as angle of incidence, then we need not require the term normal in the question, because this term itself describes that the angle which we are measuring is with respect to normal. Okay, whereas when there is given that the light is incident 30 degree with the mirror, so it is given that the reference is mirror. Okay, so in the earlier one, the reference is provided, whereas the later one, which is angle of incidence, it is self sufficient to tell us that we are measuring with the normal. So Ashwat, are you clear?
Yes,
Is your
sir.
doubt clear?
Yes, sir.
Okay, so whenever there comes angle of incidence or angle of reflection, that means we will make a normal and we will measure an angle with the normal. Okay,
Sir, but in the fifth question, even angle of incidence is mentioned, right?
in the fifth question, the angle of incidence is given. Yes,
The angle of reflection will be 30 degrees, right?
it is 30 degree. Yes, correct.
Sir, but in the answers it is given at 60 degrees.
Okay, that was error from my side when I was selecting those options. By mistake I took as 60 degree. Right, later in your score sheet, you must have seen your scores, right?
Yes, sir.
Okay, later in your scores I have corrected this mistake. Okay, so
Okay,
all
sir.
of you who have done 30 degree in your answers, that is correct. I have corrected this. Fine.
Thank you, sir. Yes.
Okay, great. Okay, this is all for the discussion of this paper. Okay, regarding the last one, in the last class which the question we discussed, that was a little bit tricky. That means if you go to your higher classes, 10th or 11th, in those classes you might encounter questions like that, because in that question it was talking about the reference as a mirror. But since we are studying with angle of incidence, angle of reflection, so your question will revolve around this type. Okay, this type. So your question, it will be given that
Yes,
your
sir.
angle of,
Sir, I have another doubt, not
yes.
related to this, sir. Sir,
Mhm,
if two mirrors are placed next to each other, and the angle between the mirrors is 60 degrees,
mhm.
then how many images, like how many images will be formed?
It will be like 5.
Sir,
There
how do we
is
calculate this?
there is a formula 360 by theta minus 1. Okay,
Okay, sir.
360 by theta minus 1. So
But
right now, put the,
360 by 6 by minus 1, right? Because 60 degrees.
yes, theta is a generalized one, so you can write theta is equal to 60 degree. Okay, but put this thing on a hold. I will teach you after some time. So I need to find like this formula is not given in your book, in your NCRT. So I have to see what thing I have to teach you so that you don't get confused. Okay, so this formula is not given in your book. Just Hmm. Okay, can you see the screen? So we are talking about light. Okay, let me get this fast. A recap of what we have done until now, and now then we will move forward. So we have learned about light, how it travels, its speed, the medium in which it travels. Okay, then we have seen the sources of light. We have also seen that uh, hmm, sources of light and the laws of reflection. Okay, what else? Then after laws, we have seen the properties of mirror.
Yes, sir. Sir, and how we see.
How we are seeing. How we see, we will come to that part. Like there is a dedicated topic of eye, so we will come to that part. Apart from this, did I left anything?
Sir, okay.
Okay, so next we are going to see the multiple reflection. Multiple reflection. Can you tell me what is multiple reflection?
So when two mirrors are kept close, that they are attached to each other, multiple images are formed. Is it?
Oh, yes, correct. Um, okay. Later you will find that there are other conditions also, but right now let's take that there are two mirrors. One mirror like this, one mirror like this. Okay, there is a coin. So you will see that there is a one image of coin in this mirror, M1. This is M2. This is there is a image of this coin also. And due to this image, we will see that there can be more images. Okay, that is clearly evident if you have gone to a salon or a barber shop.
Sir, even in malls, sir.
Even
Like
in a malls.
when two mirrors are placed opposite to each other, there will be infinite, like uncountable images.
Yes, if let's say Ashwath is standing in front of these two mirrors, M1 and M2, then Ashwath will be able to see that there are infinite number of images in this side and infinite number of images in this side. So how this thing is happening? First, let's say Ashwath is standing, then there comes an image of him in this mirror, and there comes an image of him in this mirror. But
Sir, because light is bouncing back from one mirror to another mirror continuously, and then it never stops.
yes, continuously. Okay, so let's say this is image one, this is object, this is image one. I dash. I put I dash to this mirror M dash, this mirror M, this M dash, this image I dash. So for this mirror M dash, there will be an object of this will be object for mirror M dash. So M dash will make one more image. Okay, I2 dash. For this mirror M, there will be an object of I1 dash. So it will make a mirror image of this object. Okay, so how that first the mirror makes an image, from that image the second mirror makes a one more image. Okay, that way they are making an infinite number of images. Like Ashwath said, the light is bouncing back from these mirrors. Okay, so due to this bouncing back of light, there it creates an infinite number of images. So this is evident only when there are when the infinite number of images create, when there are two parallel mirrors.
Yes, sir.
But in this case, like I have told you about coin. Okay, so regarding this coin, there won't be an infinite number of images. There could be a four. Okay, there could be one, two, three images. There could be four images or five images, but there won't be infinite number of images. Okay, because they are inclined at some angle. Due to this inclination,
Sir, if they're inclined at one angle of one, then there will be 360, sorry, 359 images.
there will be 359 images. Yes. Okay, so don't talk about that formula. I will tell you about that formula in next class. Okay, so right now, just observe that how this thing happen. You can do this example in your home also. You can take like stand in front of a mirror and put one mirror beside you.
But
Uh,
is it
yeah,
360 by the angle -1? They have taught it in the last class. I mean, when it was already done, the light chapter.
it is done in your class.
I mean, it was done by the previous was writing the chapter like
Yes.
told it is
So
360 by a -1 and this
360 by theta minus 1.
by a, I mean, by the angle of reflection.
Yes,
With
I'm representing that.
angle in which the mirrors are placed.
Yes.
Okay.
Okay. So can you see this image? So in this image, what the barber is doing, he's holding a one more mirror. Okay. So there are how many images? One image is this one. Okay. And from the same person, due to this second mirror, there creates a one more image. Okay. This is how multiple images are formed. There are other examples of infinite images. Let me show you.
Sir, this is there in the NCERT textbook, right, sir?
Yes. Okay. Like this is one example. Okay. Can you see that there are infinite number of images, right? There must be a one more mirror beside this girl, behind this girl. Okay. There must be a one more mirror due to which there are infinite number of images. Okay. You can see that there are infinite number of images. So parallel mirrors can create infinite number of images. Whereas when a mirror is tilted at some angle, it won't be able to create infinite number of images, but it can create large number of images. Fine. Let's move to dispersion of light. Any doubt in this topic? Okay.
No, sir.
Do you anyone has any doubt?
Sir,
Fine.
what if there are mirrors on all four sides?
All four sides. All four sides won't affect much. Like there will be infinite number of images in your front side. There will be infinite number of images in your right side. Okay.
Sir,
But they,
there are some places in the world where are like there is a type of room, sir.
Mhm.
Like it's in the shape of a decagon, or like it has a multiple number of sides, like 15 or 16, like that. And then there
Mhm.
will be mirrors attached to one side. Like it will be like how there will be more than like if we see in the above picture where a girl is showing, there are many pictures,
Mhm.
sorry, images,
So if
and
there
like
are
that.
some mirror in your right and left, then there will be more images in a diagonal way. Okay. So there will be more images in diagonally, right? If
Yes, sir. If it's there are four sides images, like maybe there will be images diagonally and also is front back sides also.
correct, correct, there will be many images. That's why we are calling infinite number of images. Okay, and the
Okay,
one you
sir.
are talking about is okay. Before dispersion, let's talk about kaleidoscope. Okay, the one you are saying.
Yes, sir.
Okay, so kaleidoscope is a one kind of prism kind. It is a instrument which is in the shape of a prism. So if you attach some roughly like this. So if you attach three mirrors, okay, these are shiny. These are shiny from inside. Okay, if you attach three mirrors in a shape of a prism, if you attach three mirrors in a shape of a prism and you put a cardboard outside this, cardboard outside this, okay, so you put one hole in front and one mirror in the one mirror in the back. There is one mirror in the back. Okay, these are of circular shape. So you have made a prism type shape with the help of mirrors. You have placed this inside of a cylinder, made of cardboard, and you have placed some pieces of glass, different pieces of glass of different color. Of different color. Okay, so tell me if you can imagine what kind of images you will see from this hole. If you peek from this hole, what kind of images you will see? Let me draw it with different color. Okay, if you peek through this hole, what kind of images you will see? Tell me.
Mm, sir, we'll see different shapes of images.
Different shapes of images of different pattern, right?
Yes.
Let me show you. Okay, there would be images like this. Then some images like this. Okay, it depends on the type of glasses we have placed inside this kaleidoscope. Okay, you can see that how beautiful this pattern is. So can you tell me due to which phenomena this pattern is occurring?
Multiple reflections, sir.
Multiple reflection, right? So due to multiple reflection, there this pattern is created, and kaleidoscope. Okay, and this is how you place those broken glasses. Okay, broken glasses of different color. These are broken glasses of different color, and these are there could be Okay. So the shape of this kaleidoscope is like this. Okay. So inside there is a prism of glasses. Prism shape glasses, and outside you have
Sir, prism shape mirror, right?
yes, mirror. Right, mirror, not glasses, because glasses are transparent, but we are talking about mirror. Right. So prism shaped mirrors, and we covered these mirrors with the help of cardboard. Okay, and this the end of this cardboard we have attached one more mirror, and this not mirror but a glass which contain many different glasses of many different pieces of different color pieces of glass. Okay, many, there are many, and in this side we put a hole through which we can see. Fine. Next we will talk about dispersion. So can you tell me how we can see, like there is rain. Okay, there is a rainy day. On a rainy day, when there if a sunlight comes out, then you can see rainbow. So can you tell me how this rainbow is formed?
Sir, something related to
So because white
uh,
light passes through the water
yes,
drop
sir.
and it splits into 7 colors.
Good, correct. I might have image. Yes. Okay, this is how it is happening. Earlier, I have told you about refraction of light, right? Did I told you about refraction of light?
Yes, sir.
Yes.
Refraction of light. Okay, so can you tell me what is refraction of light?
Sir, change in velocity of light due to the change in medium of it.
Good. So change in velocity. Due to change in velocity, there is change in direction also. Change in direction of light. So since this light is made up of many wavelengths,
And each, sir, from each of one wavelength to another wavelength, like each different colors have different wavelengths, sir.
yes, each color has its own unique wavelength. Can you tell me why I am saying this as unique?
Because each color, it can be purple, blue, or red or orange. If we can differentiate the color, then that means they will have a different wavelength. So each unique, different colors have their own wavelength. That's why they're called unique wavelength.
Yes. So the color has its own, like you can say, has its own patent of one wavelength. So let's say if there is 540 nanometer, okay, this is unit of wavelength. We say in the digits of 10 to the power minus 9. Okay, so if any color has 540 nanometer, so there won't exist any other wavelength of 540 nanometer. Okay, notice that 540 nanometer. So that 540 nanometer will represent only one color. There cannot be possible that single 540 nanometer can represent more than one color. So that's why I'm saying unique. Unique means that the same wavelength will correspond to one color only. There cannot be possible that you see that red is formed from 700 nanometer also and 750 nanometer also. Okay.
Sir, so the band of 7 colors is called Vijayar. Then what is spectrum?
The band of seven colors of rainbow. Band of
7 colors is called Vijayar.
no band
Of
of
rainbow,
seven color
if rainbow is
of rainbow is called picture. Whereas the band of colors is spectrum. Okay, there can be seven colors, there can be 10 colors, there can be 15 colors, but a band of colors is known as spectrum. Is this okay?
okay, sir. Band of colors is called spectrum. It can be any number, but band of 7 colors of the rainbow particularly is called a Vijayar.
Vibjor, yes. Okay, so we were talking about that there each color has its own unique wavelength. So the refractive index, the refraction happens when there is change of medium, right? There is change of medium. And each medium has its own refractive index. Do you know about refractive index?
Sir, the how much it could refract the light?
Yes, how much it could refract the light. That means if any, let's say air has refractive index of 1, that means there won't be any change in direction of light. Let's say the water has refractive index of 1.5, that means it will deviate the light that way that it won't be straight but a little bent. So if this is water, it will be a little bent. Okay, so let's say there is some other medium, let's say mercury have refractive index more than 1.5, let's say 1.8. So that mercury, what will this mercury do? This will bend this light more. Okay, it will bend this light more than that was bent in water. So the refractive index, the work of refractive index is it is with the help of the value of refractive index we can say how much this light will bend. And this
And
bend,
also, sir, then how is the refractive index related to the wavelength? How will like if an like particle with a different refractive index, how can it differ the wavelengths? Like how can the wavelengths differ?
okay, so there is clear relation between you yourself told me that this depends on velocity, right? That the velocity, there is change in velocity, that's why there is change in direction, right?
Yes, sir.
Okay, can you tell me how velocity and wavelength are related?
Sir, wavelength means the the distance of
Have you seen
wavelength
this
means
formula?
no, sir.
C is equal to lambda f, if you have seen.
See the speed of light.
C is the speed of light.
D
Okay,
and F. What is D and F?
okay.
It's such an honestly.
Forget it. You will get to know this formula. Okay, let me give you a brief about this formula. C is equal to lambda f. So C is the speed of light, lambda is the wavelength of light, f is the frequency of light.
So
So
can we
whenever
also call C as the velocity?
no, C as speed, because we always talk about magnitude. Okay, so we always talk about magnitude. When light always travel in a straight line, right?
So
So
so we can say it's a velocity, right?
no, C is always represented.
Sir,
Okay,
I have
there
a
is
doubt.
different. Okay,
Then the same
let me answer her question. So when there comes any term as velocity, in velocity we write as v, whereas we write c. So c is always with the speed. Can you tell me what is difference between speed and velocity?
Velocity
So
has
speed
both
has
direction and
distance
speed,
and
sir.
velocity has
Sir,
distance.
velocity has both direction and speed, sir. While
Yes,
c is only speed.
only speed. So
Speed is scalar.
if if we take magnitude of velocity, that gives speed. Okay,
Okay, sir.
can I write? Okay, if you haven't heard this, don't worry. Okay, so you like yourself said that the speed is the um uh, speed does not depends on any direction or whatever. Speed is just the number. So speed is just a it is just a number. Whereas
Sir,
v
so the refracting index doesn't change the how like wavelength. It doesn't. It's not related to the wavelength.
we will discuss this. Let's first discuss what we are like getting right now. Okay, we will come to the refractive index and wavelength. Okay, so right now we are talking about what is velocity and speed. Okay, speed is just a number, whereas velocity is something which has direction. So in this formula we never take direction, since we are dealing with number only. This c is a number, lambda is a number, f is a number. Nothing in this formula has direction. So direction is something known as vector. So you do not need to know about vector, but vector, if we anything which has direction, that is vector. So there is general rule in a formula. If in a formula there is vector quantity in one side, there will be a vector quantity in other side. Okay, I think I'm taking this a little far. So if you get if you get confused, don't worry. I won't talk about anything above your scope. Okay, don't worry.
Sir, can you tell
So
about that wavelength and refractive index now?
I will tell you. So just remember this formula: c is equal to lambda f. Okay, so in this we always take speed, not velocity. So this is speed of light, speed. This is wavelength, and this is frequency. So this is always related to wavelength and frequency with the help of this formula. Okay,
So,
and
but a
since
wave has a direction, right?
yes, wave has a direction.
So it can be velocity. It has a direction.
Light, you have heard until now that light is a wave, but later you will get to know that light is also a particle. So can you tell me that particle has a direction?
So, but wave has a direction.
Wave has a direction. Light has dual nature. Light shows two types of nature. It shows wave nature also. It shows particle nature also. Okay.
Yes.
Let me take one example. Like Manasvi is hmm, going from point A to point B. Okay. So if Manashwi goes to this point B with an speed, okay, I'm talking about speed of 20 meter per second, and she is coming back with a speed of 20 meter per second. Okay, so can you tell me what was the speed of her journey? Speed of
So
her,
20 meter per second.
okay, it is 20 meter per second. Now I tell you that now I ask what is velocity of her journey?
So is it 0?
Correct.
Sir,
It
how?
is 0 meter per second.
Because
How?
there's no displacement.
there is no displacement. Yes. So when you move in a circular path, so in what happens in circle, you start from this point and come again at this point. Okay. So displacement is what is the distance, what is the amount of distance you have traveled from point A, point B, not amount of distance. What is difference between these 2 points? Okay, you can say that this is difference between these two. This is displacement. And velocity is related to displacement, whereas speed is related to distance. Okay. Are you confused? Okay, Manas, we want to talk about velocity.
Sir, your voice is breaking.
Right?
Sir?
Now is it good?
Yes, sir.
Okay. So Manasvi, did you got your answer? That if
Yes.
we put the velocity term in that formula, so velocity term itself it will complex that problem. Okay. So in velocity, we need to know that how it is moving. It is moving in right, it is moving in left or up or down. So that way the problem will be complicated. Whereas if we are telling you speed means a constant thing. Okay, earlier it was going with 20 meters per second. Now it is going with 20 meter per second. That's mean we are talking about a general speed. Okay. Is it okay, Manasvi? Any more doubt?
No, sir.
Okay. So there is light, there is sunlight. Sunlight is also known as white light. This white light is made up of 7 colors: V, I, P, G, Y, O, R. Okay. This white light is made up of 7 colors. These colors, the wavelength of a color depends upon the refractive index okay, no, not depends on it. The deviation of light in a medium depends upon wavelength of light. Now don't ask me that how it depends. Okay, we are talking about general thing. So there is sunlight. Are you guys there or are you gone?
Sir, we're there.
Okay, so there is sunlight. Sunlight is made up of white light. Okay, we say sunlight as white light. Why white light? Because it contains 7 colors: V, I, B, G, Y, or R, Y, O, R, Vibgyor. So it is made up of 7 colors. These 7 colors has different wavelengths. These 7 colors has different wavelengths.
Sir, I have a doubt
Yes.
in this part itself. Sir,
Mm.
like if we saw the Newton's disk in the previous class, I think. Not when the Newton's disk is it is moved at a great speed. It spin at a great speed. Then
Okay, okay. Wait.
we can
Ashwin,
see white light.
this is a little okay. You are talking about speed and okay. You are talking about white light. Okay.
Okay.
Ask me this question after this before 10 minutes. Okay, how much is the time?
Sir, 8
Okay,
o'clock.
it is past 10 minutes.
Sir, you
Okay,
can.
you can ask me this question in next class. Let me finish this quickly. Okay, right. So we are talking about white light. So white light is made up of 7 colors with Jor, and these 7 colors has different wavelength. Every this the deviation of light. Why I'm saying deviation of light? So let's see this image. Can you see that the white light, the light which is coming from the sun, it has broken into many colors in this part? Okay, answer me. Can you see this? That this
Yes,
single
sir.
light has broken into many colors.
Yes, sir.
So this light has broken into many colors, and these colors will then come to our eyes, and we can see it. So how it is happening? That this white light has there's 7 type of colors. This 7 type of colors has different wavelength. Okay, and these different wavelength has different deviation. Different deviation with change of medium. So if these different lights have different deviation with change of medium, so it will deviate different. You can say the red will deviate less, blue will deviate more, likewise. So that's how these lights are deviated. So these light are broken into many parts, and it gets reflected inside this water drop. Okay, so this reflection also involves a total internal reflection, that is different phenomena, which I will explain you in the next class just now. So this light is
Sir, again there is a part called reflection, right? So after the light, it is separated into the different colors. Does it reflect with the wall of the water droplet,
mhm, it
or
gets I will explain you in next class. Okay, right now just
Sir,
I'm
and
giving you a
also after reflection, why is there a change in the direction again?
there
After
is no
reflection.
okay, there is no change in direction. After reflection, you are saying that why there is change in direction. Okay.
No, sir. After reflection, there's a point where all the colors are changed. Yes, sir.
Hmm. Okay. You are saying about this point.
Yes.
Okay, we need to discuss more about this.
so your voice is breaking again? Okay, sir.
Okay, sir.
Bye, sir.